Okay, so for chemistry.
Never mind, I got my own here.
Okay, so if I had to predict what the test will look like, I'd say a quarter of it would be like motion, a quarter of it would be biology, and half of it's going to be chemistry. Have you spent over half the year on chemistry?
Yeah, we did.
Yeah, we spent like.
Wait, you don't know what the test looks like?
No, like I'm still finishing it up, but like just to give you a breakdown. That's what I'm shooting for. Okay.
Wait, did you have to write the final?
Oh yeah. I make fun of fun. Okay. So be prepared for that. Okay. So you guys, to start with, we talked about like atoms and elements. Okay.
Wait, do you have like a pen or?
Yeah, that's something every day with you, you know. You're welcome. All right.
Yeah, I lost my shape. Because like I went to the bathroom and I really went on and I thought I lost in the bathroom. She was walking one shit.
Okay, so the periodic table. You guys should know the different families, okay?
What?
Like halogens, noble gases, all of those.
We're supposed to know.
Yeah.
Oh, wait, are we gonna not have a periodic table or something?
No, you're given them.
Okay.
But if I said, what do the halogens do? You'd be like, well.
I don't know.
Or if I said, what do the alkali metals do?
I also don't know.
They react with water very violently, right?
Wait.
What about the noble gases? What's special about them?
Wait, can we use, hold on.
Okay, very good. The noble gases are these ones here. They don't react with anything. Okay? So.
Yeah. Whatever, can we use these periodic tables?
I'll give you those ones on the test, yeah.
Like, can I have my own? There's nothing on the test, right?
No, I'll give you fresh ones. That's fine. Okay? So I'll give you new periodic tables. Okay? You should know things like atomic mass, atomic number. Okay? We need 4 diagrams. Okay. Okay, so that was kind of the basic introductory stuff. Well, you guys should know the 7 of them are diatomics. Okay, yeah, the 7 and 7, very good, Maddie. So that.
You're gonna leave that there,
not too far.
yes.
Okay.
You're not gonna leave that there?
So you have to memorize. Just know 7 at 7. You make a 7 at the 7th one. And then from there we went into bonding. Okay. We looked at different bonds. There were 2 major types of chemical bonds that we looked at. Anyone remember? Covalent ion. So covalent. 2. Very good, Maddie. You do know something.
I know so bad for the test.
These are 2 non-metals. Okay. The other one was ionic.
Metal and non-metal?
Yeah.
We're out of the difference between metals.
Can happen. Those are called alloys. We don't get into that in grade 11 or grade 10. Okay. Or grade 11 or grade 12. So don't worry about it. You're safe. Okay. So with covalent, 2 non-metals. Remember, you got to use the prefixes here. numbers.
So is that like dye whatever and
Yeah, like
dye it? I don't know.
carbon monoxide,
Okay.
right?
Oh wait, you don't put the one on the first one.
You don't put mono on the first, but you could have like trifluoride tetraoxide.
Okay.
Okay. With the metal, all you do is you switch the ending on the last one to I. Okay. So like sodium chloride. Okay. So here, let's just do an example. N3O2. That's trinitrogen. Dioxide. Now what if I had two of them? I got FeO and then Fe2O3. Yeah, the Roman numerals. You have to see which iron it would be. Some of your metals are, remember, multivalent. So they have more than one charge. You have to see what charge it is. So you would check your periodic table. Okay, Fe is iron. This one here has a 1-to-1 charge, right? I know oxygen has a charge of -2. So that means iron also has to have a charge of +2 for them to balance out, right? So that would make this iron 2 oxide. Now this one, I have 2 irons and 3 oxygens, so I need to balance those charges out. So that means originally, if I redid the crisscross, this iron has a charge of +3. So if I look at my periodic table, hey, iron does have a 3 charge. That's iron 3. So this one would be iron 3. Okay.
Wait, for ionic, you switch them? Like you switch the charges for all? Oh, for
All of them, you always do the crisscross. Yeah. Ionic though is mostly. Okay. What if I had something like this though? Hey, you got your periodic table, don't you?
I did.
Why did you put it on? No, no. All right, so like this though.
Oh, I wonder what's gonna play.
Try to see. CaSO4.
Isn't that calcium sulfate or sulfite?
Okay, so this here, does anyone know what these ones are called? Like this is a metal.
Polyatomic.
Yeah, these are the polyatomics. Do you need your phone up?
No.
Oh, what are you doing? You just put it away and pretend like nothing happened? I don't know. It's weird.
Ah.
Yeah, so it's polyatomic, so you just name them as they are. So you look up calcium. SO4, you gotta look at the polyatomic table on your one periodic table on sulfate. So it's just calcium. And you'll have to go back and forth like this. Sometimes I'll give you the formula. It's like the symbols, CaSO4. You gotta name it. Sometimes they give you the name and you gotta write out the formula. Okay, and I think that's the trickier one, right? You're doing it again. What are you doing? What is that? Are you trying to like listen? Music? Are you like trying to get the ocean? Like, what are you doing?
Yeah. Wait, is that actually real?
No, it's just the air. You can get the same. You do that.
I used to believe and I'd be like,
Oh
my gosh, you can hear a whale. Ocean.
Like you hear a whale. You would take it that far, Maddie. You get all specific too. Oh, it's like a northern blue whale. Okay, so that's like basic naming stuff. Do you guys want me to keep going with naming compounds? No, let's not do that.
No, the balancing stuff was kind of
Balancing's fun. Yeah, okay, so balancing.
fun. Balancing, I think, is like the easiest thing of all this. The rest of it, I cannot understand how wide it's literally just math. Chemistry is I don't understand stupid. It's so what? Biology, I don't even know what we were learning.
Biology is like this is an ecosystem. This is a predator. This is prey.
I don't know, like what?
Primary producer.
I can't everything. Wait, did I get my scientific class?
Probably not.
No.
I would have marked it on the weekend and left it alone.
You should bring it tomorrow.
I'll try to remember that.
So I can know what I, oh, okay. Thanks.
There you go. Okay, now, so balancing equations. What's on one side of the equation has to be on the other side of the equation.
Oh, it's a balance.
Oh, you got balance, bud? Yeah, boy. Let's do some examples.
I will always begin loud. Practice makes perfect, I tell you. I was becoming good. I was becoming bad last night. I saw the piano on my base, so I'm like, I don't know how to play piano.
Okay, so here's the first example. We're going to balance this. CH4 plus oxygen produces water and carbon dioxide.
How do you know? Because it has carbon dioxide.
Yeah.
And O's.
Yeah. Okay, so Peyton, big brain Peyton over there. She called this, and it's right, this is combustion. This is a hydrocarbon, that's oxygen. So we're lighting something on fire. And the products are always water and carbon dioxide. Okay, good work, Peyton. Hold on.
Stop throwing my stuff off the table.
I think someone added me to something weird.
Shush. I can't hear you anymore. Oh, no, I can't.
That's funny. Okay, so let's balance this equation. Let's see what we got here. Always leave oxygen and hydrogen to the end. So let's check out our carbons first. I have one carbon on this side, one carbon on that side. So those are good. Okay. Let's go with hydrogen next. I saw all of them, man. That's weird. I got 4 hydrogens here, right, man? I have 2 on this side. I need 2 more, right? So what do I put it to multiply? 2 times 2 is what, Maddie? 6. 4 and 4 balance.
Well, if it doesn't that mean you have an extra oxygen now?
Yes.
Or 2 extra oxygen?
Yes.
Why is there like a 1 of this?
Because I was counting. Okay. Pay attention. So now, I put this 2 here. So what that does is instead of having 1 oxygen here, I have 2. Plus the 2 from over here. So how many are on this side?
4.
I only have 2 on this side. So what do I got to multiply this by? Okay. 2 times 2 gives me 4. This is now balanced. Okay?
But
Yeah, what's up?
what about this one?
This 2 here?
How is that 4?
No, well, because I have 2 here, right? 2 oxygens. That's 2. Then over here I have another 2, right?
I thought it was supposed to be 4.
Well, yeah, but 2 plus 2 is what?
Well, so if you go to an egg,
Let's do another one. Okay?
oh, it's 4 total on that.
Yeah, so we're on total on that side.
She's like, you like groovy. She always go like this and then wrap her foot around. Done.
Oh, here we go. All right, calcium chloride plus aluminum sulfate. Produces okay. Now I'm gonna get calcium sulfate and aluminum chloride. Can anyone tell me what type of reaction this was?
How do you know? Because there's 2 things.
Yeah, they swap. The calcium and the aluminum are switched. See, like, look at it. The calcium is by the chloride. Okay, you guys, please. Okay, calcium and aluminum. Look at how they swap spots there, Maddie. The calcium's not by the chloride anymore, it's by the sulfate. The aluminum's not by the sulfate, it's by the calcium. So they switch, so it's double replacement. They both switch each
How
other.
do you just see that within like a few seconds?
Because she does all her homework. See how her book's open, she's writing stuff down. Maddie, this is all very beneficial stuff that you should be doing right now. Okay, Maya, hold on to your sheets, please. Okay, so let's balance this one. Okay, come on now. I'm going to start with aluminum.
So did you.
There's 2 aluminums here, 1 here. I put a 2 here.
You were super timely.
Okay, Peyton and Maddie, stop. All right. Now, when I'm balancing the sulfates, there's 3 of them here, right? Balance the whole thing together. Don't try to balance the S's and then the oxygens. Just balance them all. So I only have 1 on this side.
How do you already have 1?
SO4. Yeah, there's only 1 SO4 there, right, Maya? Whereas here, there's 3 of them.
Oh, because of the after.
Yeah, right, okay. So I have to put a 3 here. Okay.
But now we have 3 calcium.
Right, so now I have 3 calciums, so I need to put a 3 here. Okay, now let's see. I have 6 chlorines, but I have 2 times 3 chlorines on this side. 6. So guess what? Balance.
Okay, so what about like the half thing? So.
Oh, okay.
Is that going to be on our test?
There'll be 1. You don't necessarily have to do the fraction one. Let's see if I can.
That always seems too simple.
It is.
If it like doesn't work, then I just put a fraction.
Let's see if I can make this one might work. Like Kate and Mason.
Is this one combustion again?
This one's combustion, yeah.
Well,
You'll-
let's start.
You'll only see fractions of combustion. Oh, this one you won't have it either. You know what?
Is that a bracket or a C? That's a C. After the arrow.
Oh, that's a C. Carbon dioxide.
Or would there be a bracket? I don't know.
Here. Change it to a 6. H3H6. Okay? Now we'll have a fraction. So C3H6 plus O2 CO2 plus H2O. Right?
Wait, that's a 6, not an 8?
Yeah, I changed it. Now we'll have a fraction. All right. Okay, so start with carbons. I have 3 on this side and only 1 on this side, so I put a 3 right there. Okay. Hydrogen, I have 6 on this side, 2 on this side, so 3 times 2 is 6. That would do it. Now, if I look at oxygens, 3 times 6, or 3 times 2 is 6. 3 times 1 is 3. So how many oxygens do I have on this side? 9. Can I multiply 2 by anything to get me 9?
Why do we have 9? Oh, never mind.
Okay.
4.5.
4.5. You could. Very good. Which is just 9.
And so, like, you can do that whenever.
Yes,
or-
you can. Did you hear that, right?
That's so weird.
Yeah, it went way up those days.
It does. Oh,
It does that a lot. Hey, man, they've done that. You'll survive. Okay, sir, do you want your question? Did you be interrupted like?
I just don't know when, because sometimes I'll go like so far, it'll be like 24, beside the O2. Oh yeah, sometimes there's like 12 hydrogens.
You can, like, some of them can get quite big. And another thing that you could do, I don't recommend this, but like if you doubled all these numbers, it works too. So you 2, CH3, 6, 2.
Yes. She's back. What was that? Watch out.
Okay, like this works too. Okay. Welcome back, Hattie. Just so you know, we're recording this for Quinn, so you can hear everything. All right, so there's that. Then after balancing, we got into types of reactions.
That right there is combustion.
That is combustion, yes.
Because it has CO2, H2O, Actually,
All right, types of reactions. There's 6 altogether. The first 4 that we covered was yeah. Yeah.
Combustion. Decomposition.
Single replacement. Double replacement. And we talked also about combustion. And the final type that we did talk about, which I'll go into detail later about, was acid and base. Acid base.
Was that the OHH?
Yeah.
I couldn't remember what it was, so I just made it up.
Yeah, neutralization.
Oh, wait, no, actually, no, there is.
I can't remember now. Yeah, neutralization. Okay. Yeah, you add an acid and a base together, and you get a water and a. Very good, Maddie. Wow.
Can you go over what they all mean?
Yeah, for sure. So synthesis is where like 2 things come together to make one.
Like sodium chloride.
Yeah, so if I add like sodium plus chlorine, I get Chloride. Yes, should.
So wait, when did the diatomics come into place? When would you use those?
I'll show you here in a second. Because like what I'm gonna eventually be doing is I'm only gonna give you part of the reaction and you have to predict the products.
Oh.
Yeah. Oh. So
Oh.
you need to know like and it produces oxygen. You need to know to put O2 instead of this O. Another decomp could be like
Wait, what's the
decomposition is where you have like one thing. So here I have calcium chloride, and it breaks apart. It decomposes. And we get calcium plus. Now look, chlorine on its own is a diatomic, so I have to write it as CO2.
Oh, so it's like the opposite of well, why isn't it Cl2 and the one before?
Oh, okay, you got me there. Should be here. And then that would mean I put 2 here.
Okay.
Good catch, Steve.
So diatomics for types of reaction, do you need to use diatomics? Okay, sure. I didn't know that.
One of like there's like the positive and then one.
Hey, you actually did study for this.
I didn't know that. That's the only one I do. And then double both of them.
Yes! Whoa! There, so I gotta find some now. A single replacement.
I was forget that you like do dance. Like you just like dance. Like you don't talk about dance, but like you like actually you like dance. Yeah.
She doesn't just talk the talk, she walks the walk.
Yeah.
I wanted to say that for you.
She's always talking about the people, but like never the dance. About the dance.
Maybe they have a love dance too. Okay, so that's single replacement.
What about VR? Why does that not have a two?
Why does VR have a 2 there?
Why does it not?
It does.
No, before.
Oh, here? Because if I bonded potassium and bromide together, potassium has a charge of +1.
Oh.
Single replacement is when the metals in the reaction swap
It
places.
was
Yeah, the 2 metals. Double is the same thing, but there's a second set of anions there too. Now double replacement. See here how like there's only one metal in the reaction. With a double replacement, you're gonna have 2 metals.
Oh yeah. Is that?
Okay, so man, this is double replacement. And if you look at it, there's 2 metals in the reaction. Okay. Yeah.
Let's say NO3.
Yeah, KNO3 plus HBr using KBr and HBr. Sorry, I had to like squish that in. I'm sorry if it's tough to read. Sorry, Quinn, even though you're not watching this. Yeah, not metals. What's that? Just because it's diatomic, like it just bonds with itself when it's by itself. Then you make it Br2.
Oh, when it's by itself, you use?
Yeah, then you make it Br2. When it's not by itself, then you go with whatever the charges are and stuff. Okay.
Okay.
Yeah.
Oh, so that makes, okay. I like her, she's really nice. Look, oh, and that one, oh, yeah, you heard it. When I first was in the first, like, I didn't know she was. Like, I'm trying to cover her today. Then she also, oh, yeah, she's like in the house. Yeah, and then she's also in her first.
All right. So, do you guys want to see combustion too? Let's do combustion shit. Hey, what the heck? Even though I've done one already. Okay, so there's combustion. You got CO2 and combustion. You mix a hydrocarbon, so something with hydrogen and carbon, with oxygen, you get carbon dioxide and water.
What is C3H8?
Propane?
It is?
Maybe? Octane? I don't know. It's a hydrocarbon.
Oh, it really making. They're some of everything certified.
Oh, yeah, that's nice. There it is.
What the heck?
Okay. And then acids and bases. This is when you mix an acid.
Oh, it's my auntie. Who is this?
Now, the products with neutralization are always the same. Water. Well, not always the same, but like identical, but the same kind of stuff. You get water for sure, and then you get a salt. So, the water is made up from the hydroxide and the hydrogen. The salt is made up of whatever's left over.
I listened to. He made a song about Tara. Oh,
Okay. Any questions about the types of reactions? Okay. Naming acids. There's three types of acids. The first two unite us. Okay? You guys remember how to tell it's an acid? How to tell if something's an acid? It starts with a hydrogen. Okay? Yeah. Remember you could start to check out. Holy cow, shit. You doodle. Good for you. Okay, so unite us. So let's add something like. Okay, so these are the first two rules. So unite us and ate something icky. So this first one I wrote out was HCl2. So for how this works is you look up the name of the polyatomic. ClO2 is chlorite. So I change the ite to us. So this becomes chlorous acid. Okay. Something icky. So I would have one that starts with an 8 originally.
What?
Okay, HNO3. NO3 is nitrate. So I now would change it to nitric acid. Okay. Then the last type of acid was the binary acid. Okay, binary acids. This is just when you have hydrogen in something. Okay, a hydrogen and another element. Let's go like this. So binary means two. So I have hydrogen and fluoride. There's only two of them. This is where you change it to hydroic acid. Okay, so hydro. Fluoride becomes fluoric. Acid. Makes sense?
Yep.
Okay. What do you need help with that, Kate? I said not really. So what's wrong? Okay. We have two more things that we want to look at.
Oh, wait, I remember this. Exothermic is hot because it explodes.
Right, exothermic gives off heat. Endothermic absorbs heat. Gets cold. Okay. And then the last thing we talked about were rates of reaction. There was 4 things that could either speed up or slow down a reaction.
Surface area was one I think.
Yeah, surface area.
Is it temperature?
Temperature, right? If you heat something up, it's probably going to react quicker because you're getting an energy.
What's the catalyst one?
Yeah, catalyst. Good. You guys remember what a catalyst is?
Sounds like an enzyme.
Oh, yeah, it speeds up the reaction, like an enzyme, okay, or a catalytic converter. You add it into the reaction, it speeds up the reaction, but it doesn't get used up itself. So it can go on and do it again and again and again and again and again. Okay, surface area, temperature, catalyst. There's one more.
I remember it, but I don't.
It's okay. Concentration or the amount of something.
Mr. Whatever, what are catalysts converts metal into other substances?
There's nickel in them and stuff like that, the metals in them.
Isn't there
They're like rare minerals and stuff.
there's
Yeah, platinum, that's it. Good one, kid.
Who buys them? Like scrap.
Scrap places used to, they don't really anymore.
That seems like a pain, you have to bring a sawzall, go into someone's vehicle, chop it off,
They-
carry the head.
They're worth like $100 and some bucks a piece though. So, and at night you could walk away with like 6 or 7 of them. Yeah, go ahead. F-150s were really bad for it.
For what?
Getting their catalytic converters taken out.
Is that what they do? People just use sawzalls?
I think so, or they figure, I'm not sure how, because I've never done it. No, you're not. They're there for, environmental reasons. No, they go around, you get under the big trucks real easy, pop it off, and away you go. I'm not sure if they sawzalled or what.
I think at night it'd be better to unbolt it, because sawzall would be loud.
Yeah, and then you're like not vandalizing the vehicle, because then if you get caught, you're in more trouble. But like scrap metal places now like take down your name and all this and everything. And some of them don't even offer you that much for them anymore. So. What are we doing now? Okay, so I'll get you guys some questions.